This question is taken from the ENGAA 2020 Section 2 paper, and it is question 9. So we read, an apple of mass MA is placed on a uniform meter rule. Apple's centre of gravity is on the 10 centimetre mark. The rule is balanced on a pivot placed at the 35 centimetre mark. An orange of mass MO now replaces this apple. Now the rule balances with the pivot at the 40 centimetre mark, comparison to the 35 centimetre. What is the ratio MA over MO? So immediately we should think this question is based on moments. So we need to try and balance moments involving all the information we have, and then see how this relates to the mass of the apple over the mass of the orange. So let's try and draw our setup. So the apple here at 0.1 meters, the pivot at 0.35, and then the weight at 0.5 meters, because of the uniform nature of this meter rule. Then what about for the orange? How does this differ? Orange is still here, but now the pivot has moved closer to the weight. So 0.4 meters is the pivot now, and then the weight is still here at 0.5 meters. So what do we do now? What do you think we should do? Well, if we balance the moments, we have the weight of the apple times its distance from the pivot, 0.25, is equal to the weight of the ruler times 0.15. And then for the orange, weight of the orange times its distance, 0.3 meters from the pivot, equals weight of the meter rule times 0.1 now, the new distance between the weight and the pivot. So how can we get the ratio MA over MO from here? What should we do? Well, we should divide these equations. A common trick during natural science or engineering admissions assessment is to divide equations so that you can get ratios or some simple relationships. So MA over MO times 0.25 over 0.3 equals this. Then rearranging, we can get MA over MO equals 0.3 times 0.15 over 0.1 times 0.25. Are there any cancellations we can make in this expression to make it easy to read off? Well, 0.3 over 0.1 is 3. Then 0.15 over 0.25 is the same as the fraction 3 over 5, or cancelling 0.05 out of each. So we have 3 times 3 divided by 5. Therefore, the ratio of mass of apple to mass of orange is 9 over 5. Again, it's useful to notice, whenever we're multiplying expressions, sometimes it's best not to actually multiply each term on the top, but leave the expressions as products so that we can cancel. This makes it a lot easier to do algebra or any calculations. So our answer is 9 over 5 for this ratio.